if you haven't finished your test corrections, that'd be a good thing to do after you get your work done today. We have a worksheet today, so you don't need your laptops right now. You can close them up. Because I do want you to pay very close attention. We're starting three-dimensional shapes. So what we were doing before, we were learning the formulas for plane figures. And so a plane figure is just a figure that is flat, okay? But now we're moving into three-dimensional figures, and we want to be able to name and classify them. So I hope you know their names. So I have some 3D shapes here and over on my desk. And so first of all, we have these different kinds. I think the bottom row here are pretty easy to identify. I think we all know that a sphere is a nice, like our, Earth, planet Earth. So a sphere is round, okay, that's easy. All right, then of course we have a cone. And the cone, of course, looks like a cone. I'm sure you all know what a cone is. And then we have what would be, in this case, cylinder, yeah. So we have the cylinder. So those are pretty easy to identify. The harder ones to identify are prisms versus pyramids. So what I have here, this one is pretty easy to identify. Which one is this? Pyramid. Okay, they're very easy to identify. So that is the pyramid. So you can see that. And then what is this one going to be called? It's a rectangular prism, yeah. But sometimes it's a little harder to tell. What's this one? This is also a prism. And so the way that we recognize prisms, this is also a prism. Over here, I kind of think this one is interesting. What's this one? Not a pyramid? Ooh. Uh-huh. Yeah. So this is not a pyramid? Okay. So this one I think is probably the hardest one to identify, because we know that a pyramid comes to a point. But this one that I'm holding, it kind of looks like it comes to a point from your view, but when I turn it a little bit, it's not. How do we recognize whether something is a prism or not? A prism has two congruent bases. So I did put out the highlighters, so I really want you to have a highlighter handy today, if you need one. But a prism has two congruent bases. So in this picture, we see that we have a triangle on top and we have a triangle on bottom. And so it has two congruent bases, and that's how we can really identify if it's a prism or a pyramid. And so when we look, we want to look for those two congruent bases. So for instance, if we look down here, this one, number 3, pyramid or prism? Prism. And again, it has two congruent bases. So does base mean that it has to be on the bottom? No, it's just two congruent shapes. So when we look at number 3, it is absolutely a prism, and typically we define those prisms using the bases. So because these two bases are triangles, we would say this is a triangular based prism, all right? And so whatever the bases are is how we name them. What about number 4, prism or pyramid? Prism, what are the bases? Pentagons, yeah, we have this pentagon shape here. So there's one base, and then back here at the back edge, there's the other base. So again, it is also a prism, and the pentagon, five-sided, so this is a pentagonal. Pentagonal, T-A-G-O-N-A-L, pentagonal-based prism, okay? So we use those bases to name our prisms. Pentagonal, yeah, pentagonal-based prism. Now, when we look at this figure, this is pretty clearly what number 5. What's number 5? A pyramid, absolutely. When we recognize a pyramid, there's a few things. A pyramid, all the edges, the faces meet at a single point on top. But you should also know that it has only one base. And here's the really important part. And they are triangular sides. Triangular sides. We sort of left that word out. All the sides are triangles, and that's an important way to recognize a pyramid. So all the sides come up to a single point. I kind of like the magnetiles. This was kind of cool. So here, obviously, we have a pyramid here, and I can open. I'm going to try not to kill it here. I'm going to do it. I have a pyramid here, and you can see that all of these faces are triangles, and it unfolds. It unfolds, and you have the one base that is a square, so we call this a square base pyramid. All the other faces are triangular shaped, okay? Do you know what this is called when you unfold a three-dimensional object? Starts with an N. Called a net. A net. We're gonna look at some nets in a little while, but okay. Now, number 2 here. What is the base? On number 2, what's the base? A hexagon, yeah. So 1, 2, 3, 4, 5, 6. So there is its one base. How do you think we would name number 2? Hexagonal, yeah. You could say hexagon base if you want. Hexagon base pyramid. Hexagon-based pyramid. Hexagonal pyramid also works, but all right. This one is also a rectangular-based pyramid, but there's lots of choices for your bases. All right, let's see. What is number 5 called? Square, yeah, square-based pyramid. Excellent. And then what about number 6? What would you call number 6? Triangular-based pyramid. Yeah, triangle-based pyramid. All right. Super. Let's just look at number 8 really fast. Pyramid or prism? Prism, good. And what are the bases? Trapezoids, very good. Yeah, so a prism has 2 bases that match, 2 congruent bases, and it's really important to identify those 2 bases. And then you should also recognize that connecting the bases are all rectangles. So all of the shapes that connect the bases are going to be rectangular shaped. It's a good way to identify those prisms. So this is probably a trapezoid-based prism, sorry. Okay. Trapezoid-based prism. Oh, I got it did twice. Now, when we have these three-dimensional shapes, we have, again, more vocabulary. All of the sides are called faces. And so this is a square-based pyramid. How many faces does it have? 5 faces. Yep, it has the bottom, and it has the 1, 2, 3, 4 triangle sides. So those are 5 faces. We want to be able to count them. So that was this figure right here, number 5. It has 5 faces. How many edges, or how many vertices does it have? What are vertices? 5 vertices. The vertices are where all of those faces come to a point. So here's 1 vertice, and then we have the 1, 2, 3, 4 corners. So there are 5 vertices. So 5 faces, 5 vertices, and then edges. How many edges? What are edges? The lines, yeah, where the faces come together. So our edges are, let's see, we've got 1, 2, 3, 4 edges on top, and then how many edges on the bottom? Yeah, 1, 2, 3, 4 edges on the bottom. So we get 8 edges total. Ladies, quiet please. All right. Let's look at number 1 here. This is a rectangular prism. How many faces does it have? 6 faces. Good. Again, there's a top and a bottom and 4 sides. So 6 faces. How many vertices does it have? 8. It's got the 1, 2, 3, 4 vertices on top and 4 on the bottom. So it has 8 vertices. And then how many edges does it have? 12. Very good. We've got 1, 2, 3, 4 edges on top, 4 edges on bottom, and then we have 4 connections. So there's 12 edges. The vertices? So there are 4 vertices, the 4 points on top where they come together, and then there would be 4 on bottom as well. So on the edges, we have like the 4 edges on the top, right? And then we have the 4 edges on the bottom. And then we have the little edges that connect the top to the bottom.
For number 2, does all of the lines
yeah, all of these would be edges as well. So there's 2 edges right there. All right, how many faces on number 2? 7. So there are 6 triangular faces, 1, 2, 3, 4, 5, 6, because there were 6, because we have a hexagon. And then the hexagon makes 7 faces. Let's see. So we're going to have 1, 2, 3, 4, 5, and 6 edges on top. And then how many edges on the bottom? Another 6, yeah. So there would be 12 edges. How many vertices? 7, yeah. So there's the hexagon has 6 vertices, and 1 more at the top makes 7.
So for the edges, the top doesn't count?
Only where they meet counts. So they're I don't have a hexagon-based prism here. So on the pyramid, you see the bottom here is the shape of a square. From each point, we have an edge going up. So there's 4 points 4 points on the square, right? Each of those connects an edge to the top point. So it's not an edge, it's just a vertice. Yeah. All right. What about number 3? How many faces does that have? 5. Good. There's a top face and a bottom and a left side, and then there's a front and a back. So there are 5 faces. How many vertices? 6. Yeah, we've got 1, 2, 3 for the front triangle and 1, 2, 3 for the back triangle. So there's 6 vertices. How many edges? 9 is correct. Let's see. So my edges, I'm getting, here I have my triangle in front. How many edges on the triangle? 3. I have my triangle in back. How many edges there? 3. And then I have connecting those bases. So 3 plus 3 and 3 more make 9. Okay, let me ask you one more question. This is kind of an interesting thing. Will you add your faces plus vertices? Add your faces plus vertices. What do you get? 14. How does it compare to the edges? 2 more. On number 2, what is your faces plus vertices? 14. How does it compare to the edges? 2 more. On number 3, what is your faces plus vertices? 11. How does it compare to the edges? 2 more. Hey, let's do one more. Number 5. 10. Faces plus vertices equal 10, and that is 2 more. Hey, do you see the pattern? Hey, there is a pattern. Faces plus vertices always is 2 more than the edges. So it can kind of help you out if you were confused. All right. Turn the page. All right. So we also want to be able to recognize what happens when we slice a 3-dimensional figure. These are called cross sections. So how many of you help out in the kitchen, do some chopping? All right. And so if you take an orange, you take your orange and you chop that orange right through the center, and you pick up the orange, what shape do you see? A circle. That's a cross section. And so what we want to be able to identify are those cross sections. When you cut them, what does it look like? And so when you slice a 3D figure, the cross section will be a 2-dimensional plane figure, a shape like a circle or a square or a triangle. For example, when the cone here is sliced across, this is the cross section, and that cross section is a circle. On number 13, we have a cone. If this is my knife and it's cutting through that cone and you pick up the top, what shape would you see? A circle. So we're going to draw a circle. On number 14, if we were to cut this rectangular-based pyramid right here and you lift the top off, what shape would you see? A rectangle, yeah, rectangle. On number 15, again, if we cut through this hexagonal base, what would you see? Hexagon. I'm going to draw a hexagon. 1, 2, 3, 4, 5, 6. On number 4, what shape would you see? Triangle. Yeah, there's a little triangle right there. When you cut it, it would be a triangle shape. Now these are being sliced vertically. These are sliced a little bit differently. So if I have a cone, and I chop it straight through, what would I look at? Yeah, tall triangle. Yeah, tall triangle there. What about number 18? We sliced that vertically. What shape are you going to see? A rectangle. Yeah, it's a rectangle. What about 19? What shape are we seeing with that for trapezoid? And I could draw a little trapezoid there. What about number 20? Circle. That was easy. All right, ladies and gentlemen, that's what we're talking about today. Faces, edges, vertices, and cross sections. Do you have any questions for me? It's really easy. Really nice. Please, ladies and gentlemen, after you finish this worksheet today and turn it in before you leave, please work on test corrections if you haven't already